The British Rail Class 142 Pacer was already outdated when it entered service, and engineers knew it. It was essentially a bus body mounted on train wheels, with no real suspension to speak of. The ride was brutally rough, and noise levels were unbearable for long shifts. Drivers felt every bump and joint directly through their seats. While some minor improvements were attempted, the fundamental design flaws remained. The Pacer never truly improved and was eventually phased out by frustrated rail operators. Engineers disliked the Amtrak AEM7 because it was heavy to control and exhausting on long routes. The electrical systems were temperamental, causing random failures that left trains stranded. Visibility was actually decent, but the lack of modern cab comforts made distance running an ordeal. Climate control was often broken or non-existent, making summer routes unbearable. Although some fleets upgraded components, the basic discomfort never went away. Many engineers were relieved when newer models replaced it. The Soviet VL8 was hated for feeling dangerously underpowered on heavy freight runs. Engineers complained it strained badly on grades and struggled with full consists. The braking system was weak and required constant attention, making descents nerve-wracking. Electrical fires were disturbingly common, creating real safety fears among crews. Minor improvements were made to some systems, but the core problems persisted. The VL8 never earned engineer trust and was retired from most routes. The French CC40100 terrified many engineers, especially in wet conditions. Its early turbine design was unreliable and prone to catastrophic failures without warning. The cab felt disconnected from actual power delivery, requiring constant compensation. Heating systems frequently failed, leaving engineers freezing during long shifts. While some maintenance protocols improved reliability slightly, the handling characteristics remained unforgiving. Engineers who operated it daily never felt truly comfortable at the controls. The DB Class 403 was rushed into service with chronic mechanical issues from the start. Engineers hated how the electrical systems malfunctioned constantly, creating unpredictable behavior. The tilting mechanism broke down frequently, causing embarrassing delays and passenger complaints. Overheating plagued early models, especially during high-speed runs in summer. Although later versions received updates, many engineers remembered it as unreliable. The Class 403 never escaped its troubled reputation. Early Metro North M2 engineers struggled with HVAC systems that seemed designed to fail constantly. Air conditioning leaks affected motors and brakes simultaneously when refrigerant escaped. The propulsion controls shifted harshly and unpredictably, making smooth station stops nearly impossible. Engineers complained about poor forward visibility and awkward mirror placement for platform checks. Over time, some fleets found better maintenance solutions, but the inherent design problems remained. Many engineers celebrated when their line finally replaced them. The London Underground 1972 stock was widely disliked for feeling cheap and poorly assembled. Engineers reported constant electrical faults and failing components even on newer trains. The driving position gave engineers neck and back pain on longer shifts. Motor noise was excessive, making radio communication with control difficult. Attempts to improve build quality had mixed results at best. The 1972 stock never gained the respect of professional drivers. Early PA4 crews feared the propulsion systems that struggled badly during rush hour loading. Acceleration was dangerously slow when packed with commuters, creating schedule delays. The master controller required constant attention, exhausting engineers on the tight headways. Climate control was primitive and often ineffective in the summer heat. While later rebuilds received significant electrical upgrades, early engineers paid the price with stressful shifts. The SNCF BB67000 divided opinions, but many engineers found it unreliable and uncomfortable. The diesel engines failed frequently, causing mysterious breakdowns that mechanics struggled to diagnose. The engineer's seat was poorly designed, leading to chronic back problems after extended runs. The turning radius limitation was surprisingly restrictive, making certain yard movements frustrating. Some procedural improvements were made over time, but the locomotive never became truly dependable. Engineers distrusted the Renfe Class 269 because it felt more experimental than practical. The electrical regenerative braking system was innovative but created maintenance nightmares for depots. Brake blending failed regularly, and the dynamic brake function rarely worked properly. Traction motor access was complicated, making roadside repairs nearly impossible in emergencies. Minor upgrades helped slightly, yet the design never fully matured into reliability. Engineers hated actually operating it on demanding routes. The MBTA Orange Line 01200 frustrated engineers because it entered service before critical problems were solved. Early trains had severe rust issues that weakened frames dangerously within just years. The Westinghouse propulsion was loud, unreliable, and prone to complete failure mid-route. Door mechanisms wore out prematurely, creating serious safety concerns during rush hours. Later structural improvements and motor replacements made it somewhat more capable. However, many engineers still remembered the early models as disappointing and stressful to operate. The BR Class 158 was powerful, but engineers disliked how punishing it felt in daily service. The hydraulic transmission created awkward acceleration characteristics that caused passenger discomfort. Engine maintenance was excessive, requiring constant monitoring and frequent, expensive overhauls. The train demanded precision during station stops and left little room for error. While systems and training improved over time, its operational characteristics never softened. Experienced engineers managed it, but many described it as exhausting. The Path H and MK class earned a troubled reputation among New York tunnel engineers. Its third rail shoe design and poor electrical grounding led to arcing problems regularly. Motor access was difficult and time-consuming, making maintenance frustrating for running repairs. Door interlocks failed constantly, and engineers worried about passengers getting injured. Although some improvements were attempted over the decades, the core design issues remained. It never became truly reliable, and crews were eager when replacements arrived. Engineers found the LIRR M1 sleek but mechanically temperamental in actual revenue service. The air conditioning systems failed constantly, making summer commutes miserable for crew and passengers. The train became known for electrical gremlins that caused random system failures. While it handled adequately when everything worked correctly, reliability concerns never went away. Minor improvements helped slightly over its long career, but frustration remained common among operators. Operating the Soviet CHS-2 felt technically outdated, yet oddly stressful for long-distance engineers. Engineers appreciated its robust construction, but hated its complicated steam generator systems. Diagnostic capabilities were non-existent, with failures requiring guesswork and experience to troubleshoot. Spare parts were expensive and difficult to source outside former Soviet territories. While some upgrades improved certain systems, the overcomplicated nature never disappeared. Engineers often preferred simpler, more reliable alternatives. The SEPTA Silverliner II made engineers uneasy because it never felt structurally sound. Engineers worried about fatigue cracks and body panel separation that suggested poor build quality. It was difficult to maintain properly and prone to serious electrical issues during runs. Visibility was compromised by thick windscreen pillars and awkward mirror placement. Although maintenance procedures improved slightly over decades, the core reliability concerns remained. Engineers never fully trusted it at track speed with full loads. Engineers feared the experimental British APT because it demanded constant perfection from operators. The active tilting system failed often, leaving the train sitting at dangerous cant angles. The hydrokinetic brakes required precise handling during station approaches, especially in adverse weather. While it looked revolutionary and impressive to the public, it punished engineer mistakes severely. Some upgrades improved reliability marginally, and specialized training helped operators cope better. However, the operational complexity never decreased to comfortable levels for daily service. The Toronto subway H1 was disliked mainly for how cheap and flimsy it felt to operate. Engineers had poor forward visibility due to awkward cab window design and significant blind spots. The aluminum body developed stress cracks easily, and repairs often looked unprofessional. Electrical failures were frequent and often traced to cost-cutting in relay components. While some lines improved their maintenance schedules and procedures, the basic quality never changed. Engineers learned to cope with its quirks, but few described it as dependable.